Good morning, students. In the previous video, we had started with exercise 7.1. We are done with the first problem, which says about the finding angles of a quadrilateral when they are given in ratios. Let's see what do we have in the second one. If the diagonals of a parallelogram are equal, then show that it is a rectangle. That means we already have a parallelogram. A, B, C. Okay. Now they are telling that if the diagonals of a parallelogram are equal, then prove that it is a rectangle. Now, how do we prove a parallelogram to be a rectangle? What are the similarities of a parallelogram and a rectangle, and the difference of parallelogram and a rectangle is? In parallelogram and rectangle, opposite sides are equal. Diagonals are not equal. Okay? But the angles of rectangle is 90 degree, wherein in parallelogram it is not 90 degree. So what we have to do here is, we have to prove that the angles of each angle of a parallelogram is 90 degree. Hence, we can prove that it is a rectangle. The first step is, let's prove that both the triangles are congruent. That means in a parallelogram, diagonal bisects into two congruent triangles. This we have already done. Now in this, in quadrilateral, in a parallelogram, diagonals are equal. If diagonals are equal, take this one and this triangle. Can I tell in triangle ABC and a triangle ABC, AD is equal to BC, DC is equal to AB. This is property of parallelogram. Done? And then AC is equal to BD. Therefore, as per SSS, triangle ABC is congruent to triangle ABC. This is done. After doing that, can I tell triangle ABC, ADB is also congruent to triangle ABC? Okay, that means this triangle is congruent to this with the same SSS, because these two sides are equal, this is common, and diagonals are equal. Done? And then, can I prove that the adjacent angles, that means angle A plus angle B is equal to 180 degree? Is this correct? Why? Because these two are parallel line, and when I have a parallel line, these two angles are co-interior angles. The sum of the co-interior angles is always equal to 180 degree. That is the reason I have written. But also, when I proved this, these two triangles are congruent, then can I tell angle A is equal to angle B? Correct? This is equation number 2. This is equation number 1. Comparing, I can write angle A plus angle A is equal to 180 degree. 2 times angle A is 180 degree. Angle A is 180 by 2, which is 90 So that means angle A is 90 degree, angle B is 90 degree. Now if I know angle A is 90 degree, opposite angles of a parallelogram is also 90 degree. Angle C is 90 degree, angle D is 90 degree. That means in a parallelogram, we prove all the angles are 90 degree. Hence, it becomes a rectangle. This is how we do prove. Let's see what do we have in the next one. Show that the diagonals of a quadrilateral bisect each other at right angles. Then it becomes a rhombus. That means I have a quadrilateral. Okay? This is quadrilateral. And they are telling that the diagonals bisect each other. These two are equal. This is equal to this, and also it is 90 degree. Okay? 90 degree, and then prove it is a rhombus. Now, how do we prove that? Let's see. Now, what is the property of a rhombus? Rhombus is nothing but all sides equal and it bisect each other at 90 degree. Bisect each other at 90 degrees already there. We have to prove this sides are equal. See, as I told you in triangle chapter, the congruence is very important because it's all applicable now in quadrilateral. Now, what we have to do here is we have to prove that these two, first take these two triangles. Prove these two are congruent. Let's make this as in triangle AOD and triangle AOD. Can I tell OD is equal to OD? Then these two triangles I'm talking about. This is common. OA is equal to OA common. Then these two they have already told right 90 degrees. So can I tell AOD is equal to AOB 90 degree given, and this is also given. Therefore, as per SAS, triangle AOD is congruent to triangle AOB. Now, if I prove these two are congruent, can I tell AD is equal to AB? As per CPC. This is equation number 1. Done with this? Let's keep it. AD is equal to AB. One equation. Now let's go to the next one. Now these two I've already done. Take these two. 2 and 2. In triangle AOB and a triangle COD. Again tell OA is equal to OC given. And then 90 degree I have here. AOB is equal to BOC 90 degree given, and then OB is equal to OB common. Done. So again this is SAS criteria. Triangle AOB is congruent to triangle COD. Therefore I can tell AB is equal to this is second equation. So which order did we get? First we got AD is equal to AB, and then we got AB is equal to BC. Similarly, these two done, and do these two. Similarly, we get BC is equal to CD and CD is equal to AD. Therefore, all sides of a quadrilateral are equal, hence it is a rhombus. This is how we have to choose. Okay, next one, let's see. Okay, if each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. That means you have a quadrilateral. They are telling that this two. Now again, we just have to take these two. Let's make this as A, B, C, D. Okay. Now in this, what we can do here is, in triangle ABC and ABC, opposite sides I have already told it they are equal. So can I take AD is equal to BC and then DC is equal to AB and then AC is equal to AC, comma. Therefore, triangle ABC is congruent to triangle ABC. Now we already know that opposite sides are equal. If I prove that opposite angles are also equal, or I can prove any one pair is parallel, then it becomes a parallelogram. Now let's do one thing here. Now when I prove these two are congruent, okay, can I tell this angle equal to this angle and this angle equal to this angle? Make this as angle 1, 2, 3, 4. So I can tell angle 1 is equal to angle 2, angle 3 is equal to angle 4, because CPCT. When two triangles are congruent, the corresponding angles has to be equal. That is what I wrote. Also, I can conclude that they are alternate angles. They are alternate angles. Remember one thing, alternate angles comes when they are parallel. So when we have a pair of alternate angles, then we can conclude that AB is parallel to CD. When I have AB is parallel to CD, AB parallel to CD, and AB is equal to CD, then this becomes a parallelogram. When one pair of sides are equal and the same pairs are parallel, then it becomes a parallelogram. Students, I want you to have a thorough check on this chapter, because this chapter is completely based on the congruency of triangle and it is related to the quadrilateral, especially the parallelogram. Okay? This chapter check, and if you have any doubts, we can always sort it out in a interactive session. Thank you. Have a good day.